boy. Good boy.
Hey folks, so I managed to get this motorized dog walker here for like 40 bucks. So spindle upgrade, here we come. So this one is a Westlow Cadence 4.6 DS, and I found it on KSL, that's like the classifieds here, and I really couldn't find any good specs on it, so I kind of just bought it, and I figured for a whopping 40 bucks I could open it up, see if it's what I need, and if it's not, then just put it back together and sell it and probably get my money back. Ta-da! Doesn't look like there's much to it. So we got our motor. Turns out this one is 2.25 horsepower. That is probably the peak. I doubt that it's actually getting 2 1/4 all the time. 130 volts, 18 amps. So again, I think that's like peak. I don't think it's getting 18 amps unless it's just starting up. And then a control board. So that's going to be where the magic happens. Got to figure out how that works. Alright folks, so much to my dog's relief, this treadmill has been dismantled. So we've got all the stuff I need is down here. I think this board is in quite a few different units, but it's actually made in the same state as me over here in Utah. It's Icon Health and Fitness over in Logan, Utah, and it's a MC-60M. So I think they put these in a ton of different units, but I just figured I'd let you know that's what I'm running. So any of the wires that aren't going anywhere are just for the AC motor in the back. And then there's also a couple, if you look at the motor here, there's 2 blue wires, a blue one and then a blue one with a stripe. And that's another switch in there. It's for thermal protection, so if your motor overheats, it's supposed to shut down. So I'm thinking that could be good or bad, you know, honestly, because, you know, the motor, you don't want the motor to burn up, but at the same time, I don't want the motor to stop and LinuxCNC not to know. So if I do run that thermal switch, I'm going to try and get that Hall effect sensor to work. That way, if the motor does shut down, Linux will know and it'll shut the steppers down as well. So yeah, thermal switch is undone, rear motor is unplugged. And so I just bypassed that switch by plugging power in. Let's see, it's unplugged from the wall. Power in from here. So now the power, per my diagram here, which actually came with the machine, which was cool. When I opened it up, there's a wiring diagram. Pretty much the wires, so one wire off your AC goes directly into it, the white wire. The black wire runs from the outlet up to the big control board where you've got this little micro switch in here. From there, it runs back down through the harness, and it would run into the motor with that thermal switch. I bypassed it, so now it's going directly into the board. So I'll show you what happens when I turn it on. Alright, so it's plugged in, plug my micro switch in. There we go, boom, I've got, okay, it's kind of hard to see, but there's a light. Let's see, where's the lens? Right about, LED right there. That's saying that I've got plus 12 volts DC. Not sure why it matters about that. But now, as I command power, you should see the speed control one over here light up. I think another one does too, so we'll try it out. And remind you, this isn't hooked to anything right now. Okay, there you go. See? Oh, we got 3 LEDs. That's what you want. According to my wiring diagram, this connector on this wire, the little brown guy, it's between the, what is it? Between the white and the black wire, which is kind of hard to see on there because of the covering and stuff, but I can get to it and see it. Between the white and the black is going to be your 0 to 12 volt signal in to tell it how fast to go. So we're just going to go ahead and check that, make sure that's what it's giving it. It's on, but we're turned all the way down, which should be 0 volts. Yeah, we're measuring in millivolts, so basically nothing. Now let's turn it up like halfway, so this should be 6 volts-ish. White and black. Close enough, 4 volts. Crank it up all the way. Should be right around 12 volts. Okay, 9 volts, 10 volts, 11 volts. Now, on the output end of the motor, that's these two guys right here, black and red, so we'll just check the voltages there. Yeah, cranked it to the max, we got like 87 volts. I did this with the motor running and I got 92, so I guess it changes a little bit depending on what the motor, you know, inductive, fancy words, inductive forces and stuff are doing. But in its scales, I'm cranking it down 60, 50, 40, 30, 29, all the way down to 0. So it's acting how it should. Now the next key is going to be to getting our motor controller signal at 0 to 12 volts in here instead of this black and white one that's coming off of the potentiometer from the treadmill. Because I don't want to have this big thing sitting next to my mill. I don't know about you guys, but that thing's kind of cramping my style. I'd rather have my LinuxCNC controlling it, right? Alright folks, so the other end of where I was just probing is going to be the end of this cable here. It's got 5 wires in it, 2 of which I don't care about. The brown and the gray are the Hall effect sensor feeding into the control board, or the big dash, or whatever you want to call it, so that the guy running on the treadmill knows how fast he's going. So that's just a speed signal. These other 3 though, you got a red, a white, and a black. That's your potentiometer output off of, well, your potentiometer wires, I should say. Because the red one's an input, that's going to be 12 volts hot. The white one, make sure I'm right here. Yeah, the white one is your wiper, so that's 0 to 12 volts, depending on speed that you select. Then the black one is your low, your ground. So those are the signals. Red one, I'm just going to disconnect that one completely, not worry about it, which right now with the plug unplugged it's disconnected, so don't have to worry about that. But what I will want to do is snip the black and the white, and that's where I'm going to tie my motor controller board that I showed you last week into there. So I'll get a 0 to 12 volt signal in here. Okay, so I mentioned last week that I thought I blew my little breakout board, and so I went ahead and ordered another one and got it in. So it's that little guy right there on top, and to my surprise, it didn't make a difference. So I was pretty bummed. I'm like, man, this thing's never gonna run. So I started looking up how these parallel ports work on the computers, the DB25s. And looks like depending on your computer, if you send a signal, like the direction ones are really easy because they're just solid, they're on or they're off. And so if you probe it with your multimeter, from the pin that you're trying to test to the case of the computer, just for voltage. When it's off it should be 0, when it's on it should either be 3.3 volts or 5 volts, depending on kind of the hardware in the computer. There's a lot that I don't really know about it. That's the gist of it though. You should either get 3.3 or 5. So when I went to probe my parallel port, I was getting, with it off, maybe like 3.5 volts. With it on, it might go up to 4 or 4.25. So both of those voltages are in basically the noise range. It's floating. The voltage is floating. It's not low enough to be considered off with digital logic. It's not high enough to be considered on. So basically I'm not getting a signal at that point. I don't know if I fried a ground inside my computer or what, but my solution was to go on Amazon and order this little card. All it is a parallel port to PCI. These are called your PCI slots. Don't ask me what it stands for. And so I can give you the number and the link of it in the description. But I honestly bought this one. I don't know anything about these things. I bought it because somebody in the comments said it works with LinuxCNC on Amazon. So I said, yep, that's the one I'm buying. I don't even have the right size little bracket for the back of it. And so I'm hoping that just leaving it there and being very careful when I plug it in for now will work. I ordered more, but they're coming from like China or somewhere. It'll be a few weeks probably. So you got to change a thing in your HAL file to let it know that you're using that port. And I am going to make a software video. It's coming, like a setup LinuxCNC video. But for now, just letting you know that that's what happened, and it actually turned out to be an easy fix. Luckily, I didn't fry the computer, but yeah. My house is making noises. So that's where I'm at. I plugged that in, I specified the right port, and now I have a CNC machine again. at least for the X, Y, and Z axis. And so now we're gonna risk cooking something else, trying to get this spindle going, but gotta make it happen. When we left off last week, I had my Arduino hooked to this breadboard with the motor controller. So, to recap here, we've got the Arduino providing PWM into this board, which is providing an analog 0 to 12 volt signal out, which is routed into this board, the Treadmill controller, which is using that signal to vary its 0 to 90-ish volts coming out of this thing to this motor. Okay, so the board is still hooked up. The only thing that it's using is this little switch. So we'll shut that off. We'll go ahead and plug in the microcontroller, which is this guy. So you can see the motor controller turns on over here, Arduino turns on. Then we'll go ahead and plug in the original Treadmill wire. So that's good. Now, make sure that our little knob on here is turned all the way down. Okay, so that's down. So we'll go ahead, we'll plug this guy in. Now we get a light on the Treadmill controller. And this is where it gets a little western. You gotta hold on to the motor while you're turning the knob, otherwise the motor wants to run away from you. So holding on the motor, you slowly turn it up. And there you go, we got some motion. So, with it in my hand, I'm not gonna crank it up too high, but you get the idea. We've got PWM coming out of there into here, analog coming out of here into here, and it's using that analog signal to control this motor. So with that, I should be able to replace the Arduino with my PWM on the LinuxCNC. So that'll be the next step. Alright, so this has got to be the sketchiest thing wiring-wise I've ever done, so wish me luck here. Okay, we've got the Arduino now disconnected, and now you see those two red wires. One of them is a ground, so I have a common ground between my parallel port, or not my parallel port, my breakout board. Right there. So one's a ground for the breakout board, the other one is my PWM signal. I went and wedged some wood in the bracket on this motor so it can at least turn slowly. And I've already checked with a multimeter that my PWM output is what I think it is. It's 100 hertz and it's going, you know, from 0 to 100%. I'm just going to barely make this thing turn, assuming nothing fries. So here we go. Let's go ahead and give this thing power and see what happens. I'm honestly a little nervous right now. Let's plug her in. Let's give the motor controller power, or I guess the small one. Okay, so we've got lights on that. So far so good. Now the treadmill. So far so good. Spindle is off on LinuxCNC, so we'll give it power here. Oh no! Alright, we popped something again. Darn it. That's my ground fault again, so I don't know what I'm doing wrong. Well, looks like there went my brand new parallel port board. So I'm getting tired of this. I think at this point the plan is going to be to order a new board so that my machine hopefully runs, and that was the only damage. I don't particularly like that C6 board. I just feel like it's such a roundabout way to do it, but I got my spindle working with it, so I think at this point, until I can figure out what the heck I'm doing wrong, I'm going to go ahead and just get my machine running with the C6 board and call it a day, call this project complete. Okay, so it's the next night. What I think is happening is that common ground that's going, I've got going from my my breakout board down to the little L298 motor controller board. I think that that's providing a path to ground from that motor or from the treadmill controller, and that's basically going through the shielding on my DB25 cable, and then it's grounding out on the case of the computer, triggering that earth ground and popping my ground fault isolator. So, and in the process frying some ground trace or something on that board, on the parallel port board. So I kind of started thinking about it last night and kind of had an aha moment that I've got all these components that work with this breakout board. What am I doing differently? So the first thing I did was I went and grabbed the C6 board since I had it working. So I grabbed my C6 board. First thing I wanted to look at was where my stepper signal and my ground go into this board from the DB25 Breakout board, because I wanted to see what it's doing and how they're grounding it and how the signal's working. And lucky enough for me, I could actually trace it back. I'm not going to try and do it on the camera here because it'll just get blurry probably, but you can trace it right into, the ground is bridged across 3 of these pins, and then each one of the inputs goes to a corresponding pin on this one chip right here. So lo and behold, I type in the number and guess what it could be? An opti-coupler. It's 4 opti-couplers in one chip there. So this board's using 3 out of 4. So it's got 1 for your stepper signal in, the step signal, and 2 for the relays over here. So that got me thinking, okay, this signal goes in here and it returns back out through the ground on the DB25. The grounds and the power are totally separate. Like you run power, where do you run power? Right here. You run power and ground into here from a 12 volt source. And if I remember right, they said do not ground this with your other ground or it will have issues. So I'm pretty sure I've been doing just that. I'm basically cross-pollinating my board, for lack of a better word. I'm sending current from one board to another and hoping that it's going to return to the right board somehow. So that's where I think my biggest issue is. I haven't been running an opti-coupler, and somehow I'm like batting 1,000 with my limited supply of just random electronic components. I got like 5 or 6 of these little ICs sitting around, all different types, and I managed to have an opti-coupler. So basically very similar to this. I think mine might be obsolete by today's standards, but it'll do for some testing, I'm sure. So my plan, instead of running a common ground, is obviously not. I'm going to have a separate power supply, which I guess I already had. I have 12 volts going to the L298N. So instead of the L298 getting the PWM signal straight out of my DB25, it's going to go to this opti-coupler, and then it's going to get grounded back to the DB25. And on the L298 side, it already has a 5 volt output. I'm going to route that 5 volt output to the opti-coupler to pick up that signal, and then that's going to basically be pulsed with PWM, and it's going to be fed right back into the L298 board on the PWM input. And so I think that's going to solve my problem. So with a resistor and an opti-coupler, I don't think there's any way I could hurt my machine, my DB25s, or any of that stuff. If I was going to damage anything, at this point it would be on the other side with the Treadmill motor controller or the L298 board. I think at this point, last night I was ready to just give up, use the C6 board, call it a day, have a working spindle, be happy with life. I think I'm going to try this one other way to do it with the opti-coupler. If that doesn't work, I'll throw in the kitchen sink at it, buying the new, whatever I blow up, I'll buy new stuff, get it working, and then I'll use the C6 board. It's just driving me nuts because it should be so simple. You've got a pulse, you got to smooth it out and feed it to the motor controller. Like, it shouldn't be that hard. So that's what got me started in it in the beginning, is I look at the C6 board, and not talking bad about their company or anything, but I look at it and I go, why are we taking a stepper signal to convert it to an analog signal and then modifying a HAL file to even make it work in the first place, when LinuxCNC has a PWM Spindle output already configured in their config files, and I can just get a PWM signal, and PWM should be pretty easy to work with. It's just a pulse and a duty cycle. So I'm like, man, I paid $40 for this C6 board, and I feel like it shouldn't be that hard. I know some smart electronics folks could probably knock this out in an afternoon and have it working, but I don't see it out there, so I'm trying to do everyone a favor and get something together that people can follow and make. We'll keep at it. This week was kind of a bummer, but it happens, and I'm not an electronics guy, so I'm learning, and I'm having fun learning. It's interesting stuff, and I'll get there. I was just reading that well, Elon Musk and SpaceX, they blew up like their first 3 rockets, so that costs a lot more than my little $10 or $15 circuit boards I'm blowing up over here. So, so that's all I got for this week. Have a good one, guys. Yeah, this has nothing but trouble written all over it.